In this video, we'll discuss linear inequalities, and to be a little bit more specific, in two variables. Linear inequalities in two variables. If I were to give a definition of a linear inequality of two variables, it would be something that involves algebraic expressions that have more than one variable separated by an inequality symbol. Just as we see in this example here, 2x plus 3y is less than negative 3. Before we actually get to solving linear inequalities in two variables, I want you to remember that the solutions to these things are very similar to the solutions to linear equations in two variables. They're the ordered pairs that satisfy the linear inequality. All right. And so I have an example here where we're going to determine if the ordered pair is a solution to the inequality 2x plus 3y is less than negative 3. All right. And then in order for us to do that, right, we have to plug the 0 in for x and 0 in for y. We have our x and our y coordinates. Plug it into that inequality there. So I get 2 times 0 plus 3 times 0. And we're trying to see if that is going to be less than negative 3. Well, 2 times 0 is 0, and 3 times 0 is 0. And of course, we know that 0 plus 0 is 0. And so we end up with the inequality that 0 is less than negative 3. And that is a false statement. 0 is actually bigger than negative 3. It is on the right-hand side of negative 3 on the number line. And so we'd say that no, this ordered pair 0, 0 is not a solution to the inequality. All right. What I want to do now is actually get to graphing. Because there are infinitely many solutions to inequalities or linear inequalities in two variables, we have to graph in order to show those infinite number of solutions. And so here are some steps that I can take in order to graph these linear inequalities in two variables. The first thing I want to do is I want to graph the linear equation that's related to the inequality. All right. And what I mean by the linear equation that's related, if I look at this example down here, it says y is less than or equal to 4x minus 8. The linear equation that's related to that one is the equation y equals 4x minus 8. So we already know how to graph that line, and so we're going to use the same exact techniques we use in graphing that line in order to help us start by graphing this linear inequality. One thing that we're going to have to be careful about is whether we're going to use a dashed line, as we see right here, or a solid line, which we see right here. We use a dashed line for a less than or a greater than, and we use a solid line for a less than or equal to or a greater than or equal to. And basically what that means, if I want to use a dashed line, it's kind of like when we used an open circle before. It means that the actual points that are on that line are not included as part of our solution. And if I use a solid line, those points are included. Okay? And so once we graph the line, we've got to show or shade where all of our other solutions lie. Right? It's either going to be on one side of the line or the opposite side of the line. And to help us do that, we're going to choose a test point that's not on the line to determine where the solutions lie. All right, which side of the line that we need to shade our solution set. So let's look at this example here. I've kind of already started it, but we have that y is less than or equal to 4x minus 8. And one of the first things that I like to do when I'm doing these is to remind myself of whether I'm going to use a solid line or a dashed line. In this case, since I see that this is a less than or equal to symbol, I am going to use a solid line. And I'm going to graph this equation right here, y equals 4x minus 8. That line, that equation has a slope at 4. Remember, when we're dealing with slope, to see our rise over our run, we can put it over 1. That means we're going to go up 4 and to the right 1. And our y-intercept is at 0, negative 8. And so that's our starting point. And so if I go to my graph over here, my slope and my y-intercept, of course, we're going to want to start at our y-intercept. And in order for us to start at our y-intercept, right, negative 8 is on my y-axis here. And from that point, I want to go up 4, 1, 2, 3, 4, and then to the right 1, and I have another point on my line, right? And of course, I'm going to connect that with a solid line. And that is my equation graphed. Of course, this is an inequality, right? And so my solution is either going to lie on this side of my line in this area over here, or it's going to lie in that side of my line over here. I got to figure out which one. And so I'm going to go up here to the last step here, which is to do a test point. All right. And when you do a test point, you always choose a point that you know for a fact is not on that line. And one of the easiest test points is the point 0, 0. All right. Notice 0, 0 is over here on this side of my line. And I'm going to plug 0 in for x and y into my original inequality, which is right here, to see if I get a true statement or a false statement. So let's do that. Plug in 0 for x and y. I'm going to get 0 is less than or equal to 4 times 0 minus 8. Okay? Let's see if that is true or not. Well, 4 times 0 is 0, and if I subtract 8 from 0, I get negative 8. If you think about this, this is going to be a false statement. And so since this is false, and the point 0, 0 is on this side of my line, then I know that my solution has to lie on the opposite side of my line, which is this region right here. And so I need to shade my solution. And so I'll do that right now. And it really doesn't matter what color you use. But I'm going to shade on that side of my line to include all these points over here as, part of my solution. And so all of these points over here, and you don't have to be perfect in shading, but all of these points on that side of my line, including the points on my line, are a part of the solution to that inequality. That means any point over here, I can choose any point over here, plug it into my inequality, and I'll get a true statement. That's the whole point of shading this and solving these linear inequalities in two variables. Let's look at one more example. In this example, we have x is greater than negative 3. X is greater than negative 3. All right, again, one of the first things I always remind myself of is whether I'm going to have a solid or a dashed line. Since I don't see an equal sign under that inequality, I'm going to use a dashed line, and I'm going to remind myself, dashed. Now with this dashed line, it's actually going to be the line x equals negative 3. That's the associated equation that's related to that inequality there. X equals negative 3. And so if I want to graph that line, we have to remember that anytime when we have only one variable and we're talking about systems of equations graphed in the xy plane, it's either going to be a horizontal line or a vertical line. And in this example here, since it's x equals a number, it's going to be a vertical line. So I'm going to have to draw a dashed vertical line that goes through x equals negative 3 on my x-axis. All right, so negative 3 on my x-axis is right here. And so I'm going to draw a dashed line. Okay, so I dashed it in. And now it's time for me to look for a test point. All right, again, I'm going to use the point 0, 0. Now, although I have x equals 0 and y equals 0 in this ordered pair here, my inequality, my original linear inequality only has x. So I can only plug in 0 for x. So what I'm going to get here is 0 is greater than negative 3. That is a true statement. And since it's true and 0, 0 is on this side of my line over here, then I'm going to shade in this side of my line. And this is where all of my solutions lie. And so any point that's not on that line but to the right of that line, any point I can choose, I can plug into this inequality here and I'll get a true solution. All right? And this concludes our video on linear inequalities in two variables.